Hello everyone, welcome back. This is Python's fundamentals, and this is what I would call Python Basics Part 1. Today we're going to go over just the basic stuff, like if you were starting at the beginning and you never had any experience with Python, and how these tutorials are created. They're in the correct order of learning that my preference for learning Python. So in this video, we're going to cover the basic structures of Python. I actually made notes just to make sure that I understand what we're going to cover. So we're going to cover the keywords in Python, uh, identifiers, comments. We're going to talk about intro to the print function, different types of statements. We're going to cover the introductions to variables, um, like how to instantiate variables, and then also just talk about a little bit how variable referencing work in Python. Um, if you're connected to other languages, you can kind of see how it works. But to some degree, everything is kind of class based. And when you create objects in Python, if that object is created and it's located at a memory location, when you create a new object, even if it's not equal to the variable of the other object, and if it's equal to the same number, that number is still stored in a reference memory location. So I want to kind of go over that basics principles as well. All right, let's get started. So again, I've rethought about it. I know in the earlier video I said I would jump between using Spider and using Jupyter. I think for these first sets of videos, especially the intro videos about the basics, the list and strings and whatnot, I'm gonna use Spider. So everything's gonna be Spider because Spider has a very easy GUI, built-in GUI system. So it'll be easy for me to explain to you what's going on in real time instead of having to teach you a bunch of new commands in Jupyter that you'll need to do to be able to do the exact same things. All right, let's go ahead and get started. All right, what we want to do start first. Uh, I like using Spider, and I like it to be laid out like RStudios. So first, and you don't have to do this, but right now the editor and the console window and the variable windows are set up like this. I prefer the editor to be right above the console and then have this area on the right side set aside for the variables and for the files. So I'm going to do this switch by just going up here to view. You have window layouts, and they actually have a RStudios layout. This is the layout I'm going to use. So when I click this, you'll notice everything has changed. So like you have your variable explorer on this side. By the way, if you want to clear this, just type in CLS and it'll clear. If something is in your console window, that's just a basic command to clear what's being seen. But anyway, now what I write up here, when I run my commands, they'll show up down here. All right, so over here, these are my files. So right now I'm pointing to that same area where Jupyter points to, where users Michael's area. That's where it's at, because you see it up here. It tells you that you are in users Michael, and then these are all the folders and files in that area. So I can go to the different files and folders this way, but this matches if you open up your file explorer, go to my computer, you go to your users folder, and I'm MICH, and this matches. I'm gonna close out what you see down here. So this is only going to show what you're actually pointing at. So if I were to change this working directory, say if I change it to, I don't know, my desktop, if I select this folder, these folders down here readjust to point to that folder. So if I save anything, it's going to be saved in the location where the working directory is located. So one of the things I normally do, and I'm not going to be saving things today, but when I start up a Python project, I create a folder location and I make sure that I'm pointing this directory to that folder location. So any file reads and save are all relative to that folder location. We won't really have to do that in these tutorials because we'll create the data, real time. But in later tutorials, like outside of Python, fundamentals training, we will start talking about file structures and stuff like that. All right, so getting started, what I want you to do, there is a library that comes with Python called uh, uh, keywords. And how you access different libraries, you use what they call the import command. So we're going to use one import for this set of modules, and that import is called keywords. Now, what I would like to do, if you're following along, I'm gonna write this in a way that if you follow along all the way to the end, your script will look like my assignment scripts. So you'll be able to go back and reference your script. So I would say write the comments, write everything, so when you come back to it later, you'll know what you need to do. And I'm going to do this going forward. I won't mention this every video, but going forward, all my scripts that we do in the tutorials, I'm gonna write it as if you was going to store it for later to do something, either for your assignments or do something for your company or whatnot, or if you're just trying to generally learn Python. All right, so what I want us to do first, I'm gonna resize these so we can have more on the screen. So you just drag the little windows, dragging these down. All right, so first I want to import a library. So to make a comment, use the hashtag symbol. So anything I write here after the hashtag symbol is not being read by the editor. Like for instance, if I take this away, it's going to give me an error stating that it's undefined. It's like it thinks it's trying to be assigned this as a name. But with the hashtag, I don't have to worry about that. This is how you do commenting. This is what it's called. So to create a comment, you need a hashtag, and then you can write, it in Word form or English form or whatever language form that you would like to write it in to be able to do it. So I'm gonna say import keywords module. And to import that module, any package that you want to use that you have installed, or we talked about installing packages in the first video, you always have to import it every session. So like if I close this out and I reopen it, I'm gonna have to re-import it because you need to import it during your working session. So I want to import keywords, and if you press tab, it'll show you like all the different things that you can do. So I'm gonna go down here and click on keyword and press tab again. So now imported keywords, and then I'm gonna do control enter, not control enter, shift enter to run that line of code. Oh, it shouldn't have been capitalized. It's lowercase. My thing trying to be too smart. Go to the end of it, press enter. I'm sorry, I made a mistake. It's keyword, not keywords. Control enter. Here we go. All right, so we've imported keywords. That would give us access to all the keywords that are native to Python, because these words are important. These are words that you don't want to write over or set objects. You don't want to personally use these keywords in your project because Python is expecting these keywords. So let's look at them. So I'm gonna write a comment that we're going to print out the keywords. Okay, and to do that, you'll call the print function. So print is how you print out to the screen. So if I were to just do the basic print, say hello world, I usually use this when I'm trying to start any kind of programming assignment. If I hit print and then do shift enter, you'll see down here it prints out hello world. If you get something like no module is found for keyword, you make sure you run that line of code. Now you remember I changed how mine's work. Mine's a shift enter now because I wanted mine's to match how you do single line runs for Jupyter Labs and Jupyter Notebooks. So if you wanted to make it like mine, so you go to tools, you go to preferences, and then you go to, I think it's keyboard shortcuts. And in keyboard shortcuts, you scroll down. There it is, shift return, editor, run selection. So I've changed run selection to be shift return. So this is the same as this button here, which is also run selection. If you just press this, So it says run selection or run current line of shift return because I've changed it. So yours is going to be something else. I don't even remember what it is. I think it's like F9 or something. I chose shift return. So anytime you see something written down here, I'm pressing shift return to make it happen. So if you're following along, just make sure anytime you see anything down here, don't forget that you needed to press shift return to get that to work. So if you get errors like this, that's what that error is about, because it can't find the module because you haven't imported it. All right, so keep going. All right, so what I want to do is print out the keywords. So I say print, and I take this word. Since I don't have an alias, I can just use this name, keyword, keyword tab dot, and there's a thing called KW list tab. Shift enter, and you see down here, these are all the keywords that are in native Python, like with no packages, in general. You got false, none, true. You got parsers, and, as, cert. These are different words that Python uses as keywords that means certain things. So if you ever wanted to see the list of them, that's how you can get the list of all the keywords that are available in Python. If you want to see the total count of those keywords, there's a linked function, and what the linked function does, it will count each element in a list. So each one of these things I'm talking about, I will do in-depth videos about, like list, strings and stuff. But as of right now, just go with me on this. So what this returned back was a list because it has square brackets. Square brackets represent a list, and each one of these things in here is considered an element. So if I wanted to get the total number of keywords, you would use the native linked command, which is len, stands for len, and that will return you back all the keywords. But that also will return back all the items in a container, which a list is considered a container type. It will return back all the items in any container type, whether it's a list, a tuple, a dictionary, and so forth. We're talking about traditional Python. All right, so if I want to see the total number of keywords, I can type print. I'll do it this way. We want to store it. So if we wanted to store it as a variable, we just write the name of it and then put equal signs, and the results of that will go into that variable. And I'll talk about variables a little bit more detail even in this lecture a little later on. But if I say a variable that we call total number of keywords will be equal to the linked, which is a function that's inside of Python, and functions in Spider, in my version of Spider, are going to be orange. So the linked means I need to return back that linked. This represents the list for the keyword. So I take this, open brackets, type in keywords list, and I press shift enter, and what that does, it stores the value of the total number of keywords in the list. So as you can see on this side, we haven't really talked about the IDE. It shows you the value. So the name of the variable that was created is total number of keywords. It is a int data type, which we'll talk about a little more. It's a size of 1, meaning it's only one value, and then the value is 36. Now you can also print out this as well, because a lot of times you might not have these type of GUI. So down here, to see it in your console, you would just say print, and then the variable name. I type in total, hit tab. When I see it pop up, hit tab, and then shift enter, and it will print down here that is a 36. Okay, so you'll notice different colors for the keywords as well. I want to show this. So like if I were to write down some keywords. All right, so we said false is a keyword, true is a keyword, return is a keyword from looking down there, finally is a keyword, and none is a keyword, and assert is a keyword. You'll notice that they have different colors and whatnot. If I'm not mistaken, I think orange means that it's a number or a parameter. So parameter, P-R-A-M-E-T-E-R, or parameter. So what that means that, you know, true and false technically are numbers. I mean, true represents 0, and we'll talk about the true represents 1, false represents 0. Or it can be a parameter, like it could be part of a function, like something within a function. It also, orange is native built-in functions too. Built-in functions are the color orange. In regards to purple, if I'm not mistaken, purple is special, what they call special keywords. And then light blue, and I don't think it is. I think in Spider, in traditionally light blue means operators. But I think for me, on my machine, operators like, you know, minus, you know, times, they come in white. They're not light blue on my system. So I just wanted to show, like, these are different keywords. Keywords going to have color differences, and the colors are not as important, you know, at this stage of your Python journey. But the colors do mean things. But the biggest thing to learn from this, just don't overwrite these. My entire career, I've never overwrote a keyword of any language, more or less than Python. So make sure you're aware of the keywords and go from there. All right. The next thing I want to talk about is identifiers. So identifiers. Identifiers also can be called variables, in my personal opinion. But identifiers is what in your code that's referenceable, that's tied or referenced to that object. For instance, we did it up here when we said this is an identifier and it's equal to the length of the list. So the identifier is actually referenced to the memory location. 36 is created, it's stored in a memory location, and then total number of keywords is the identifier that is referenced to it. So that's kind of what identifiers are. The formal term is identifier. So if somebody's talking to you from an academics perspective, but you also can look at identifiers as just in general, just a variable, you know, as a variable. So let's create some. So say if I want to create a couple of identifiers. Now the cool thing about identifiers in Python, you don't have to tell Python what type of identifier it is. You can just, it figures it out once you assign something to it. So like in traditionally, like especially C++, I'm not sure, it's been a while since I've been in C, in C# as well. You have to say string identifier. If it's a string, you have to say the keyword string is this object is a string. This name is actually from the string, and then the object that goes into it has to be a string. So if I try to take an object that's been assigned a string and pass in a integer, a number, it would break. Where in Python, that's not the case. Your object can be whatever you want it to be. It could be, it'll change dynamically. I'm gonna show it to you. So for instance, say my name Michael is an object. I think so Michael. Now it's identified. I'm gonna equal it to the number 1. If I hit Shift Enter, you'll see now this identifier is a int size 1 and it has the value 1. But you know, it's not special. I could say Michael is equal to false. Shift Enter, and it automatically switches it. And you notice the color changes too. See over here, that's why I really like this environment variable suite over here, a variable explorer, is that it tries to color code based on types. So like you notice how the Boolean is red and the int is orange, right? What if I make myself have what we call a float, which is a number, you know, any real number. It's not just whole numbers. So 2.1. So now it's a float. So you see the float and the ints are colored the same way. But now, you know, Mike is a float. What if I wanted Mike to be 2.1 plus 1j? Yep, it can deal with that. It knows that it's a complex number. So we got a complex number. And what's interesting, I have to be honest, you know, I have never used complex numbers outside of teaching it. I've only used them like in the classroom. I know they have value, but I just, in my world, I've just never had to use complex numbers, but they are present. But what I'm trying to show here is that Michael is very dynamic in the sense that you don't have to assign it specific variables. You can instantly change it real time. It is some feature that we take for granted in Python that's not true in older languages. To be able to have a single variable and I could just switch up that variable in real time it's a really cool feature of Python. All right, so I think I covered that. What I also want to cover is just going through comments. So I'm gonna make a section. We call this the identify variables. You see how to instantiate variables, and you can name them what you want to. This section I'm gonna call it commenting types or commenting. All right, so what we have so far, what you're aware of, is the single line comment. So that's what we've been doing. You have the single line, and if I want to make another comment, I just can't start here. I actually have to press the hashtag and then write another line, next single line. And again, you can write exactly what you want to write in that statement. Well, my bad. This is single line, right? Let's do this. One line. Multi-line. A single line comment would be a comment, and I say this identifier is a int or integer. So that's a comment I want to make. All right, a multi-line comment. So I want to make sure I'm very thorough with these videos. I don't want to leave anything to chance. So a multi-line comment, multiple comments, is considered when you have more than one. So, but you're still using a hashtag per line. So I'm gonna copy this one where I said the identifier is an integer. And you might want to have some other additional statement. So on the next line, you'll go down and you'll say that identifier is an integer. Please don't use a bool for this identifier. For some reason, maybe a bool breaks it. So what it is, you have it like line by line, different types of comments. Okay, and then the last way of doing comments, there's like three I would say maybe there's more ways, but these are the three ways I use. The last way is what they call, you can have a comment section. So you can put a set where you can just like build like a paragraph spot where you can just write freely until you're done. I think they call this comment section, or a comment block, or comment block. So here, if I use 3 single quotes, one gives you 2, right? Then I click one more, and then I do it 3 times. So one will give you 2, but just press it 3 times. It'll automatically know what you're trying to do. And then press enter, and then do 3 more quotes. 1, 2, 3. So now you have these 3 quotes above you and 3 quotes below you. Okay, so now you can write anything. So you can say the identifier is a integer. Press enter. Please don't use a bool for this identifier. Thank you for reading. my guide, and then a lot of times I might, Hamilton, maybe creation date. I might have a date when I actually created that, and then anything else that you would like to have here. But what the cool part about this, you do this when you're trying to write a lot. So maybe trying to explain a function or explain a variable. You can write a set of comments that are ignored by the compiler. So the compiler is not looking at these comments. They're ignored by the compiler. So you can just keep up documenting your work. And again, the formal documenting approach I tend to use is both with what they call it, Markdown. Markdown is like a formal way to like write up an actual experiment in document form for Python and also R as well. But also I like to do them with Jupyter Notebooks too, because of the way the cell structures work in Jupyter Notebooks. You can like make a recipe and have it all recipeed out, and then have comments, blocks, blocks that represents pieces of code, and we'll talk about that later on. So that's the reasons for why we do what we're doing. All right, so next, so we talked about that. I think we need to talk about the print command. So print command, we've done it a few times already. I just want to have a session for it. So print command is how you print onto the screen. So again, we got those variables created. So if I wanted to print Michael, it's going to print out the last thing that was saved, right? I did all of these, but that's the current value. Or I can print what's the other one called? Total number. I just hit tab. Total number of keywords, 36. Say you wanted to print them like side by side, right? There's two ways you can kind of do this, but one of the easiest ways is just print and use a comma. I mean, I'll talk about this later. So if I could say print Michael, comma total, and then hit enter, so it prints them right beside each other. So this is the first one and this is the second one. Okay. I guess I'll do one more. Another thing I tend to do, and I probably will, you'll see me do it a couple of times. I guess I do it now. Sometimes I create print statements and then use arguments to represent where the data go. I think it's nice to know this technique. These are like the most common techniques of using the print statement, but I'm gonna give you at least one advanced one that might make it easier when you're trying to write out your results. So say I had a string. I'm gonna call it str. Oh no, I'm doing what I told you not to. Let's just call it output. That's the string. And say the string is the total number of keywords is, and then I put squirrely brackets. Okay. And the what's the other one? I forgot what the other variable was. My name. What is my name? And it's a complex, and the stored complex number is, and then I'm gonna do squirrely brackets again. Okay. So this shift enter, that creates this string. So because I have this string created, print has what they call a format option. I'm trying to think about in my head right now. I'm trying to make sure I remember where the format goes. I think all I have to do is say print output, and then the two variable names, Michael, and then what did I say first? Total number of keywords. No, I gotta do total number first because the order matters since I didn't put no numbers in it, and then Michael. Okay, when I hit shift enter, That's not how we do it. Give me a second. I think there's a, maybe it's here. I'm doing this real time. Bear with me. Yes, format is actually a method. All right, so then I put, so let me show you what I just did. So if you hit dot, the string itself has a format. So you do dot F, it should pull up this little window and you can see the different objects. So what we want to use is just traditional format. So you can type FORMAT, open brackets, and in these brackets you'll put your variable names. So I want to put in keywords. The total number needs to go first. Just copy it, put that in there, and then I want to put in Michael second, because Michael would be second based on how I wrote the actual statement. So when I do shift enter now, oh, I forgot a parentheses. Close the parentheses and shift enter, and now you see the mistake has fixed itself. The total number of keywords is 36, and the stored complex number is 2.1 plus I to the J. All right, so, and then one more little thing about this, I'm gonna say, write a comment. This is without setting the argument numbers, and I'll explain that in the next second. So what I want to do is copy these two, and then I'm gonna paste here, and I'm gonna say this is with setting, and let's set them. So what if so right now I will have to make sure that wherever I put these parentheses, the order in which the objects that go into the format needs to be in the same order. But what if I wanted to switch these around? Say I didn't want to have to keep up with this ordering system. Say I stored it and I wanted to have Michael first and total number of keywords second. So let's change it. We're gonna put Michael here. We're gonna put total number of keywords here. Okay. Now when I run this line now, you will see shift enter that is wrong, right? The total number of keywords is not this, but that's what it says, and the stored complex numbers is this, but that's wrong. So the quick fix to this, and this is the reason why I made it a second section, you can set which one goes with what number, and this is indexable based on 0 indexing. So if I want, so from an indexing perspective, this is in the 0th place in the format, and this is in the 1's place. So I need this in the 1's place to show first. So I put a 1 here. Okay, so that's in the 1's place, and it's a 1 because there's only 2 objects. Because there's 2 objects, Python indexing system is 0 based. What do I mean by that? I didn't plan for this part, but I'm looking up Paint to make sure you understand what I mean by that. All right, so you know you have objects. Okay, and then you know, each object is 1, 2, 3, 4, 5, 6, and so forth. All right, but when I say indexing, I'm trying to draw with my mouse, guys, so bear with me. This object is, says this object is in the first position. It's in the first position, but it's represented as the 0th index. So you're in position 1, but to access you, your access number is 0. So this is what this means. So this is in second position, but the access position is 1. So and so forth. So this one would be 2, 3, 4, 5. So 0 to 5 represents the objects in 1 through 6 position. This whole concept, you just got to, in Python, you have to like really lock it in. I think a lot of times when you first learning, this is a struggle point because you're just not used to the whole indexing concept. And you'll see many examples of this, but just in general, when things are in a list or an object or an array or whatever, 9 times out of 10 they're going to be zero index in Python. So you have to learn how to what they call slicing, and we'll have whole videos on this, but slicing through an index. But so right now, don't save this. So here again, this is in the ones place because it's the second element in the format, and this is in the zeros place. So let's put 0 here. So now when I run, first I have to run the output line to make sure that the 1 and the 2 show up. So if you double click here, you can see that it's a 1 in the first place and there's a 0 in the second place. All right, so I'm gonna close this down, and then I'm going to run the second line, and now you'll notice that the total number of keywords is 36 again, and the stored complex is 2.1 plus 1j. So I think from a print command perspective, and don't get me wrong, there's more ways to do print statements, but these are like the most common ways to do it when you're learning Python. So let's see, looking at my notes, we talked about that. We talked about the print statements. That's what we've been talking about now. Okay, so now we're going to talk about statements in general, just to make sure you understand what we've been doing. So there's statements are pretty much, let's do this, we've already kind of covered them, I just haven't talked about it. Statements are instructions that a Python interpreter can execute. It's kind of like a formal definition. So like we are in a Python interpreter, and in it, all of these are Python statements. So these are statements that it can compute. So for instance, when I say A is equal to B, A is equal to 5, B is equal to 2. So those are both identifiers stored, right? A statement would be like, then C is equal to, A plus B, and as you see, C is 7. So A is 5, B is 2, C is 7. The C is an actual statement that it can interpret, which means that Python understands C is an identifier that's equal to an operation, an addition operation of 2 other integers. So it's an integer math operation that returns back an integer of size 1 that's equal to 7. This is what we call a Python statement because it's written in a way that it can understand. I can't say the word plus, right? This Python cannot understand. If I were to run this line of code, it's going to give me an error because it has no idea what P means. That's what it kind of breaks. But it doesn't have any knowledge of what plus means. But if I say the minus sign, it's a 3 now, or anything like that, it will be able to do it because it falls within what we call Python statements that are interpretable. So I just want to make sure when we say statements, that are what we're talking about. Got variables. Let's see. So variables. I think this is where I might got my I guess terminology. Sometimes I think here earlier I wrote that identifiers equal to variables. I guess that's not true per se, but it's okay to know. I guess I'll be formally correct. Identifiers are not equal to variables. Identifiers actually point to a variable that's located in some memory space. But in general, people look at these as variables because they represent something, right? They're holding data. But the formal definition of variable would be a Python variable is reserved memory location to store values. So that's the variable. It's where the reserved memory is. So a variable is created. You know, when we run lines of code, they really run from right to left. So 5 is created and stored in a memory location, and then A is assigned to 5. So 2 is created and stored in a memory location, and then 2 is assigned to B, and so forth. I'm gonna show you an example. You know what? I'm gonna go down this road. I'm gonna show you an example so that it'll be clear on what I'm talking about. So a variable is, finish this. A variable is created the moment you first assign a value to it. So that's key. All right, so let's look at these. We already got variables. We got them here, and there are some key functions in Python you can kind of check out, like some deeper understanding of like how this is stored. So for instance, we have A, B, and C, and they all have different numbers, right? Which means that their computer reference location is their computer reference location is where these numbers are stored. So for instance, if I were to, there's a function called ID. Let me talk about that right quick. We got the ID function, and what it does, it returns the identity of the object. Okay. So this is also going to let us know the true identity of its location on your computer. And then what we can do after that is use the hexadecimal function to figure out what memory location it really is. So for instance, if I run, I'm just looking at ones we've created. If I say print and then I use ID, which is the command A, you're going to get this number. This number is actually where your computer, where the number 5 is actually residing on your machine in RAM or in memory at the moment. To see it kind of like how you would see it more like a computer scientist, if you say print and then use the, I think it's hex, yes, hex, then ID, and then A. So what I did, I have this part runs like this, that gives me this number, then that number is converted to hexadecimal form and then it's printed onto the screen. So this is the actual memory location for A right now. So I'm gonna do this for A, B, and C. A, B, and C. Okay, so you'll see I must have messed up. Oh yeah, I missed the parentheses. Okay, so I missed the parentheses. Shift enter and shift enter. So you notice that these three have you know what, I like to do it the way I showed you above. It's kind of hard to read like this. Give me a second, I'm trying to see something right quick. Nope. Oh, trying to switch it back to files. All right, so what I want to do is print it all in one line so we can just see it side by side. So I'm gonna comment these out. Y'all can do the same thing, you keep it like that. Just I don't want to like delete anything. I'm gonna create another print, and all this print is just what we have in the inside. So I'm gonna take this one and put a comma. This will be practice for you. If you're not familiar with Python, this will be good practice. Just a Control C. It's like Windows. If you're working with like Word, it all works the same. All right, so when I print this, you can see that the addresses, right, are all different. Now, What if I created a new variable and I called it, that's D. D is equal to 5. What you might think is, all right, D, new variable, it created 5, and now it's it has its own new memory location, right? But if I were to print out A has 5, right? So I print out A, that here, and then put a comma and print out D. I'm gonna switch this to D and press Shift Enter. This error means that let's talk about it. Syntax error means that that's an error in my coding. The interpreter can't read something, so it's trying to give me a warning. It's pointing to this, the error happens here, so it's trying to let me know that something is wrong here, and what's wrong is actually parentheses. I need to have another parentheses here. Parentheses. Oh yeah, and I need one here too. So I see it kind of threw off some things. So this first parentheses, you see how they match? Like when you click here, the greens. When I click on this one, you see how it matches, and when I click on this one, it matches. That's how you can check. When you click here, Spider will give you identifiers. Like it'll show green and which parentheses it think it is. So you can try to fix your parentheses issues if you have issues. So use that to do it. When you get it right, you should be able to do Shift Enter. And what you're going to notice, they're at the same location. And that is what I mean by object referencing. So on the computer, Python doesn't recreate numbers that it already knows. So once you create a number, that number is stored in reference. You set a variable, it's going to be in memory and in a memory location the whole time. So when you create new variables that reference either that number or object, it's always referencing unless you forcefully tell it to create a new memory a copy of that number into another memory location. Now we're not going to cover that here, but just to let you know, at this stage of your journey, when you create a number and you change it, and or even if you sum, say you both have 5 and you say 5 plus 2 is 7. If 7 hasn't already been stored, it's going to create a location for 7. So if any other variables have a combination of giving 7, so if you had a number that was like 1 plus 3, which is 4 plus 3, if that number adds to 7, that variable that's holding that number is going to reference to that same locations of 7s. They're not going to create new 7s. So I just hope you got that part. All right, so I just wanted to show you, making sure that you understand the concept of how these things are stored and stuff like that. Let me check my notes right quick. Yeah. All right, so I think I've covered all I want to cover in part 1 of Python Basics. So I like to do recap. So what did we do today? The first thing we did, we talked about the keyword class, the keyword module, not class. The keyword module that's within Python that you have to import. We talked about that you must use the import command when you're importing. Otherwise, you can't use the functions that are referencing this object. We talked about how to print out, how to see all the different keywords. We talked about setting identifiers and how to use the linked function. Remember, the linked function gives you back all the total number of elements within a list, or the total numbers of elements in any container. The print command prints values onto the screen. We talked about how these things here match up with what's going on into the environment windows. We discussed keywords, the different keywords that are available, and there are different color schemes. And these color schemes could change from computer to computer, or instantiations of versions of Spider IDE as well. They could change. We talked about variables, how when they're created, they're stored in a memory location. We talked about that down later, but these are the different identifiers for different types of stored variables. These identifiers do not have to be constructed, or you have to have instantiated to say what it is before it's assigned. They can be assigned dynamically, so we talked about that here. Commenting different types of commenting types. So you have the single comment, you have the multiple comments, and then you have the comment blocks that are here. All right, and then you have the print command. We talked about how to single print is what we're doing here, and then how to print multiple objects at the same time, in which that there will be separated by a space. We also talked about a very convenient way of printing like statements, and you want to print out like a set of things and make it more dynamic. We talked about how you can set these little brackets to represent where variables should reside inside of your print statement. And then we use the format key, format method, to be able to assign the order of the variables here. And if you don't put any numbers, this is automatically 0, 1, 2. And we also showed how you can switch it up by actually adding the numbers. So this is flipping the index. We flip the words here, we flip their positions, and then we flip their positions in the statement, and they both produce the same results. We also talked about how the interpreter works. It can provide interpretations based on statements that are written in a manner of Python. You can't just use regular English words. You have to use that style of programming that Python understand. And then lastly, we just had a short discussion about how variables are referenced in Python. They have memory locations. They sit there and they always reside there for that instance of the software that run. And then any new variables you create, if they're the same with another variable, you're actually just pointing to that reference location, not creating a new copy of it. And that's automatically done. Like Python is by reference natively. You don't have to put the star and the ref keywords and stuff to say something that's referenced in Python. It does it natively. I showed you how to find where the stuff is located on that memory locations, like in case that's something you might want to know from a software engineering perspective. And that's that. Again, I hope this was valuable to you. In the next video, I'll be going on what I still continuing down the road of Python basics, but we'll be covering just another set of basic stuff that you need to know before you start moving into a deeper level of Python. Again, thank you for your time, and I hope you have a great day.